Howdy, this video is going to cover inverses. There are 4 types of inverses we will be doing: coordinate pair inverses, table inverses, equation inverses, and graph inverses. Pretty simple. First off, coordinate pair inverses. You're given xy, the inverse is just yx. Wow. Example. So 1, 2, the inverse would just be 2, 1. And then we have a set of inverses, a set of coordinate pairs. So that's going to be the inverse 2, 1, and then -1, 3, and then 5, 4. That's the inverse. Just switch x and y. Yay. Okay, next. Now we have our table inverses. Also, really simple. We have our x column and our y column. Switch them around. What happened? And that's pretty much it. Alright. Equation inverses. So given any equation, switch x and y and solve for y. So if we're given y equals 2x, all you do is switch x and y. You'll have x equals 2y, and then solve for y, so divide by 2, and you'll get y equals x divided by 2 as the inverse. Okay? Now, they are noted as f -1 of x. That's how you would have your inverse look like. So instead of having y, well, instead of starting with y, you would start with f of x equals 2x. And you're going to replace fx with y. And then, after you're done solving for y, you're going to replace y with f -1 of x equals x divided by 2. Okay? Okay. So, when showing that an equation is an inverse of another, perform a composition of functions, meaning we substitute the inverse into the actual function. Okay, to see if you equal x. If you equal x, it is the inverse. If you don't equal x, it isn't. So, for example, let's use these two here. Okay, so I'm going to substitute this x here for our function x divided by 2. So we'll have f of f -1 of x equals 2 times x divided by 2. And 2 divided by 2 cancels, so you're left with x, which is your inverse. Yay, awesome. So that's how it works. Next. So our example. Let's find this inverse here. So the first step, we're going to replace f of x with y. So y equals x minus 1. And then second step, we're going to switch x and y. So x equals y minus 1. And then third step, we're going to solve for y. So add 1 to both sides. So you'll have y equals x plus 1. Last step, we need to replace y with f -1 of x. There you go. That's it. So our second one, first step, replace f of x with y. Y equals x squared. Switch x and y. X equals y squared. And then now we need to solve for y. Now our y is squared, and the opposite of squaring is square rooting. So to get rid of square root both sides. And you'll have y equals the square root of x. And now replace y with the inverse notation, which is f -1 of x equals the square root of x. Okay. And then our third example, we have f of x equals x squared plus 1. So very similar to the other two, but combined. So this time we need to, again, replace f of x with y. So y equals x squared plus 1. Switch x and y around. So we'll get x equals y squared plus 1. And now to solve for y, we first need to subtract 1 from both sides. So x minus 1 equals y squared. To get rid of the square, we just square root both sides. And we'll be left with y equals the square root of x minus 1. And then now, to note the inverse, we need to replace y with f -1 of x equals square root of x minus 1, which is the inverse of that. Okay, awesome. Okay, now our graph inverse is really simple. Here's our original graph, and I want to find the inverse. So what we're going to do, we're going to take 2 points, 3 points, 4 points, whatever. So let's take these 2 points here, and let's find those coordinate pairs. That's going to be -2, -2, and that's going to be 1, 4. Now, how do we find inverses of coordinate pairs? Switch them. So then our inverse is going to be -2, -2, and 4, 1. So then you plot those, -2, -2, 4, 1, right there. Oh, look. Awesome, we already graphed it. So, really simple. Find the points of your graph, switch x and y, regraph it. So here's an example. We have our quadratic function. And let's go ahead and find 3 points. Let's find the roots, which are here and here, and then the vertex, which is here. So that's going to be -3, 0. What's next? Oh yeah, -1, -4. And then 1, 0. And now we're going to switch x and y. So we're going to have 0, -3, -4, -1, 0, 1. And so now plot those, 0, -3, -4, -1, and then 1, 0. And there you go. There's your inverse right there. Now, some inverses are not functions. See, this here is a function, but guess what? This here is not a function. And why is it not a function? Because of the vertical line test. Vertical line test, we have 2 intersections, which is a no-no. We only can have 1 intersection. So since this is not a function, we should note the inverse of quadratic functions are not functions. Okay, make sure you know that. Now, last slide. Sometimes our tables aren't functions either. Because if you see here, we have -2, -1, 0, 1, 2, 3. They're all different numbers, which is good. And here, we have 4, 1, 0, 1, 4, 9. We have same numbers, 4 and then 1. But it's okay to have the same number in your output. That's okay to have the same number in your output. But if we find the inverse, guess what? We now have the same number in our input. And we cannot have the same number in our input. That's a no-no. It's the same thing as the vertical line test. We'll have the same, but we'll have 2 intersections for the vertical line test, which is a no-no. So keep in mind, if you find the inverse of your table and you have the same number in your input, so here we have 1, 1 and 4, 4 in your input, it is not a function. Cannot have repeats in the input. Not a function. That's it, guys. Thanks for watching. Do your homework, do your notes, etc. Bye.